Okay. It is called relations and functions. A function is a relation with only one x value for every y value. Okay, which out of all that mumbo jumbo really is just saying x cannot repeat. I don't know. Okay, so that's the first thing I wanted to talk about. Before we get into anything else, though, there's some things that I need to make sure vocabulary-wise that we have. So typically, I've been having you make like a little table, right? Yeah. And I've been listing this as x and this as y. X has several different things that refer to it. Instead of x, there's some other words that mean x. So I can say independent variable. The independent variable is always your x. Input, the input is always your x value. And there's one more word that means x, which is domain. Any of these four things refer to the x value. Okay? For the y value, y can be called dependent. It is also the output. It's what you get when you put x into it. It's the output. The y values are the range. And there's one more thing that means y. And it is, and we talked about this the other day, it is f of x. This is called function notation. So anytime you see f of x, that's how you say it, right? F with a parenthesis x, that just means y. That's all it means, okay? So are we good with this vocabulary? Have we heard all of these words before? All right. Okay. So let's start by talking about what the domain is, because I'm going to assume that's one of the words we haven't heard before. Domain. The domain are your x values, which we just said, right? Listed in numerical order. The range is your y values listed in numerical order. So, for example, I'm going to smooth this up for a little bit here. Oop, too far. A little too far. All right. If you had a list of points, so let's say I have the points 2, 1, 1, 7, 3, -1, and -1, 4. Okay, I have 4 points up there. My domain is my x values. All of my x values in each of those points. So I would say my domain, put a little colon here and a bracket or a parenthesis. Okay? And we put our x values in numerical order. So the lowest x value we have is -1. Then we have 1, 2, and 3. Our range is our y values. Again, we write range, little colon, parenthesis. Our y values, and again, we put them in numerical order. So we have -1, 1, 4, and 7. Okay? If any number happens to repeat, you only list it once. Okay? So you don't have to write it more than one time. So we can actually use these to do what we call a mapping diagram. So I need to talk about that. Mapping diagram goes back to our table with our x and our y. And we're going to list our domain for our mapping diagram has to be in numerical order. So it's really just our domain listed vertically. So we're taking our domain. I'm going to go -1, 1, 2, and 3. I do the same thing with my y values or my range. Again, numerically, -1, 1, 4, and 7. To do a mapping diagram, we go back to our points and we connect the points. So we take our x value and draw a line to our y value. So I'm going to draw a line from 2 to 1. Then I'm going to draw a line from 1 to 7. And I'm going to draw a line from 3 to -1. And then -1 to 4. This is a mapping diagram. From the mapping diagram, as long as there is only one line coming from each of those x values, then it is a function. If you would have had 2 lines coming from one of them, you would say it is not a function. Okay? So, first 2 problems you have in your homework today are exactly this. So, here we go with example number 1. States domain and range, then use a mapping diagram to determine if the relation is a function. All right, so you're going to have a list of points. Let's say I have the points, let's go 0, -3, 1, 4, 2, 2, and 1, 7. All right, so the first thing we're going to do is list our domain. Our D, domain, parentheses, our x values in numerical order are 0, 1, and 2, because there's 2 1s there, right? Our range in numerical order, -3, 2, 4, and 7. Whoops, and 7. Didn't write that very good. Let's try that again. So any questions so far? Now we make a mapping diagram. So right next to it, I have my x and I have my y. I'm going to list my domain vertically in numerical order, 0, 1, 2. I'm going to list my range numerically, -3, 2, 4, and 7. And now I go ahead and connect my dots. 0 to -3. 1 to 4. 2 to 2. 1 to 7. Correct. This is not a function. Why is it not a function, Keegan? Okay. All right. So any questions? This is what you have to do for the first 2 problems. We're all good? Okay. All right. Next thing I need to talk about is the vertical line test. The vertical line test is a test to determine if a graph is a function. So, if when you draw a vertical line, you're going to draw vertical vertical lines and if each only cross one time, I'll just say once, then it is a function. So let me explain, okay? Let's say, and I'm not going to put the background graph on it right now. So let's say you just have a graph that's in a U. We've been doing those, right? All right, and I go and I draw vertical lines down. How many times do each of these vertical lines cross the graph we have? One time. So this would be yes. Okay? If, let's say, well, let's do it this way. Let's say I have something like this. If I draw vertical lines down, this one only crosses once, but what about that one? Crosses more than once, so this is not a function, or we can say no. Yes. Okay, so did that clarify that a little bit better? Okay. So the next couple problems we have, and I'm going to do an example of. You good, Natalie? Almost. Okay. All right, so here's example number 2. This is what you have to do for 12 and 14. Use the vertical line test to determine if a function so again, I'm just going to do it without the background graph there so you can see it a little bit better. How about this one? Draw it through. This would be no, all right? How about this one? This would be yes, exactly, good. So the other word they sometimes call this is the pencil test. So if I were to take a pencil and just take it across my graph, right, because the pencil is a vertical line. If I just take a pencil across my graph and it only crosses my graph one time, that's why they call it the pencil test, same thing, okay? All right, so you have 2 problems like that. Super easy, right? Yep. Awesome. Example number 3. Better get out of that color. Example number 3 has to do with plugging values in. So this is going to 16 through 20, kind of, sort of. All right. Directions say find the range given the domain. So before I even write the problem, let's talk about what that direction means. Find the range. What are we finding? The y value given the domain. So what are we being given? The x or the input, right? Okay. So you're going to get something that looks like this. F of x might be g of x, might be h of x. It's all function notation, right? Equals, let's say, negative 2x plus 4. And then after it, in a little bracket, they're going to give you like 3 or 4 numbers. Let's say negative 2, 0, and 2. We have to plug each one of those in and find the range. So I'm going to start by plugging the first one in. Now remember, this is y, so I don't plug it in over there. This is just y equals negative 2 times negative 2 plus 4. Negative 2 times negative 2 is 4, plus 4 is 8. I have f of x equals negative 2 times 0 plus 4. 4, good. And then I have f of x equals negative 2 times 2 plus 4. 0. All right. Now that I've plugged each one in, I have to find my range. R, colon, parenthesis, or a bracket. And how do I have to list those numbers? Yes. So you put 0, 4, 8. Any questions? Nope. This is all you have to do for these. Do you want another example like this? Okay. Okay, I'm just making sure. All right, here's example number 4 then. Example 4. Find the domain and range and you're going to get this little tiny story. My car, I do, my car gets 23 miles to the gallon. Not when you drive 45 minutes every day one way. But anyway, 23 miles to the gallon. My tank holds 25 gallons? Okay. 25 gallons. Find the domain and range. All right, so first of all, we've got to figure out between the gallons of gas and the miles we travel, which one is independent and which one is dependent. Yes? So let me say that again. Okay? Out of what we have up here, I have gas in my car, and my car can travel a distance, right? Which one of those is the independent variable? The gas in my car or the distance we're going? The gas in my car, right? Because that is. Okay. So that means my domain has to do with the amount of gas in my car. Everybody agree there? Okay. So first thing, I'm going to move that up a little bit. My domain. What is the least amount of gallons of gas I can have in my car? 0. I can have no gallons. 0. Less than or equal to, and of course domain is the x value, less than or equal to, what's the most amount of gallons I can have in my car? Very good. All right, so that is my domain. I can have, excuse me, I can have anywhere between 0 and 25 gallons of gas. Okay, that's what that means. Now I want to talk about the range. The range is the miles I could drive. If I have 0 gallons in my car, what is the least amount I can drive? 0. Okay, so 0, less than or equal to y, because range is y. And then what's the most gallons I can drive on a tank of gas? 25. Good. All right, so this means that I can, if wherever my gas is, I can drive anywhere from 0 to 575 miles, right? That's all you have to do. You have a couple of problems where you got to determine what is your independent, what's your dependent, and then what their domain and range is. What's the least to the greatest it can be. There, I don't know, a few of them, and then everything gets mixed up again, so it's kind of a general idea, all right? So let me do one more example real quick. So like this kind of covers 22 and 28, all right? So if you want to put 22 and 28 there. Example number 5, last one. Determine if the relation is a function. You're going to be given a table sideways, x and y. So let's say I have 0, 2, 1, 4, 0, 6, 3, 7. All I need to know is this yes or no. It is no. Why is it no? Good. No, there are 2 zeros, right? Again, remember what I said in the beginning. As long as none of the x's repeat, it is a function. Okay? Correct. So this is no, or not a function. Okay? All right. Huh? You still have 5 more minutes. You can work.